Hi guys, all of you, good evening. Guys, in today's session, we are going to discussing about Docker. What is Docker? What is the importance of Docker? In which areas we are using Docker? Okay, these are the very important things we are going to discussing about this one. Okay, guys. Uh, Docker also one containerization software. It's a platform. It is a platform, and it is designed with a set of tools to simplify development, deployment, and the scaling of applications by using this Docker containerization. Containerization is a lightweight platform compared to virtualization. So, what is virtualization? Where we are using that virtualization? So, see, guys, already this is the virtualization tool. VMware is the virtualization tool, and ESXi also virtualization tool. VirtualBox also virtualization tool. Like that, so many tools are in the market. So what is the use of this one? What is the use of this virtualization technology? And before that, before this virtualization technology, what was the technology is there? See guys, this is the virtualization technology. So what is the use of this virtualization? Yes, here we can create multiple operating systems. We can create multiple operating systems. Okay, guys. With this virtualization technology, what are the advantages? And nowadays, compared to this Docker containerization, what are the disadvantages with this virtualization technology? Before this virtualization technology, there is a traditional technology. What is the use of and what are the advantages and what are the disadvantages of traditional technologies? Before coming one new technology, that is the technology, that is the useful technology. But whenever we are going to inventing one new technology to improve to improve usage and to decrease that cost cutting, or else whatever the problems are there with the new technology, traditional technology is a little bit difficult to handle that. Of course, there are lot of difficulties or disadvantages with the traditional technology. All servers are individual servers, and huge manpower required, huge place required, huge electricity required, huge network required, so many resources required for managing the traditional technology. Finally, the result also little bit not easy to get compared to these are new technologies. So that reason, some of the guys introduced this kind of virtualization technologies. By this virtualization technology, what we are doing on one single physical mission. See, this is one single physical mission. High-end resources. With the high-end resources, one physical mission, on one physical server, we can create like this number of missions. See guys, these all are servers. Whatever we are seeing here, these all are the servers. Each and every server, each and every VM, virtual machine calling as a OS. The base is OS. whatever you are seeing here, how many servers we are having here? These all servers are starting with OS. Starting with OS. And keep in mind, every VM should have these resources. Every VM should have these resources. RAM is required, processor is required, disk space required, and what is that? Devices, network adapters, sound, everything required. Without that, we can't. But here also we are having disadvantage. See, guys, in real time, why the virtualization technology? Why we are using virtualization technology? And why we are not using virtualization technology? Why we are trying to avoiding virtualization technology? And almost 70 to 90% we left from the traditional technology. Almost 90% we are not using that traditional technology due to lack of resources, lack of problems. So many issues are there. The main thing is lack of resources. Not able to invest. We can't invest that much of resources. Resources nothing but these are the resources. See, every mission should have that RAM, processor, disk space. Okay, these are the physical resources, and what is the place also, manpower also, networking also. Okay, like that, so many. Every server should have that. Even in the traditional technology also. Even in the virtualization technology, we should have these resources. Without resources, we can't move forward. But compared to traditional, virtualization technology is giving little bit a good result. That's giving much more help to industry. And third one, latest technology, that is the containerization technology. With that containerization technology, if you compare to traditional and virtualization, what is that? It is virtualization. That is very easy, very easy to handle, and less manpower required, less hardware resources required, and the software resources also very less compared to this traditional and virtualization technology. Okay, we'll see that. See, guys, this is the VM. This VM should have an OS. On that OS, yes, we should have that RAM and processor and disk space. Finally, how many VMs we can create like this on one physical machine by using this virtualization? How many VMs we can create? What is our requirement? How much we are having requirement, and how much we are having resources on this physical machine? See, here we can see the how many processors we are having. If you observe this one, just click on this one, not this one. Better to use new one. We can't increase. Yes, now you can come here. Just click on that. See, guys, total how many processors are there? See here, total. Here we don't have that, just one. Yes, total 24. Sorry. Yes, 24. Okay. Total number of processors, core processors. Number of total processors, core processors, and 32. See, guys, it's not supporting 32 processors. So finally, how many we can? Maximum how many we can? 24 core processors. But here we are having 12 two processors. Physical processors are 2. That having each processor having 6 cores. One physical processor having 6 cores. Here I have that two physical processors. So that reason we are getting 12 cores. Again that 12 core dividing by, sorry, multiplying by 2. That 12 core processors multiplying by 2 is a total 24. That 12 which we are going to what is that multiplicating with 2. Those 2, that, sorry, the extra 12 are threads. Extra 12 are threads. That's calling as a threads. Total 24 core processors maximum we can. And coming to RAM, yes, here we can see that total physical processors. See guys, these are the physical processors. One, generally in laptop you are seeing that, if you are seeing that a laptop or if you are using that a desktop, we will get only one processor. We will get only one physical processor. But these are the business servers. Which one I am using right now? This is the business server. I mean that rack server which we are using in the real time data centers. I am using this server, and this is the maximum 80 GB RAM. 80 GB RAM. In this limit only, with the 24 core processors and with this 80 GB only, we can utilize. How many VMs we are going to creating? How many VMs we are having? These all are under 80 GB RAM and 24 core processors. And here we are using that OS also. This is also OS. For this OS also we should leave some RAM and processor. Without RAM and processor we can't run this OS also. This is the base OS. Which one we are seeing this Windows? This is the base OS. After that we are going to creating VMs. Every VM should have that RAM, processor, disk, OS and all. But just imagine it. Here we are having that, just I am having that 80 GB RAM and 24 core processors. The total 24 processors, yes, I am giving two processors per Windows OS. I am giving the two processor to this Windows OS, and 2 or 4 GB, 2 GB or 4 GB I am using to this Windows OS. Out of 24, two processors we are going to deducting. Next, what are the remaining processors? 22 processors, 22 core processors. We should use that core. Next, out of the 80 GB RAM, just imagine it, I have given that 4 GB RAM for this Windows OS. Next, remaining 76 GB RAM we can utilize for these VMs. If I run these all VMs at a time, this server should not support me. It's not able to handle these all VMs at a time. See, here how many processors I have given that to two processors. Here how many I have that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 I have that. 21, yes, we need to remove these almost 3. It's mean 18 servers are there. 18 into 2. Yes, guys, 18 into 2. Do you have that 36? We don't have that much of processors. And I have given that 8 GB RAM. I have given that 8 GB RAM for each server. Here 18 servers are there. Do you have that 180 GB RAM here? We don't have that much of RAM here. We are having only 76 GB RAM and 22 core processors. So here also Here also we can't manage. If I run these all servers, this server, the physical server, immediately it will stuck or it will shut down due to lack of resources. This is also one problem here. But compared to traditional, if you go to traditional, we need to buy each one physical servers. Here total we are having 18 servers. You need to buy 18 servers, physical servers. How we can handle those 18 servers? Not only if you go to real time, not only 18 servers. Now you can imagine it that ChatGPT and Google, who are using that huge infrastructure for maintaining this data, YouTube data and Google data. You can imagine it. These servers should not support. They want to buy crores of physical servers. For today's business, already they are having some crores of servers, physical servers. If they want to run each and every VM as a physical server, I don't know how many servers they want to buy. I don't know how much manpower required. I don't know how much place required. And that what is that electricity bill also. Okay, networking components. It's too much. Okay, it's not possible to handle. They are also using this virtualization technology. They are also using virtualization technology. They are buying that high-end servers, physical servers, and that OS they are using that this virtualization technology directly, bare metal OS. After that, they are going to creating like these VMs. After that, they are going to configuring network. After that, they are releasing to air. But by this one also, we are having a lot of problems. Imagine it. If we want to configure this environment on physical, what is that virtualization technology? If you are going to set up a new environment, you want to buy servers. You want to bring into that physical location, that point of data center. And you should have that manpower. You should have that cabling, networking, and operating system engineers, application software engineers, and configuration engineers. If you want to set up that much, minimum it will take 2 to 3 months for one small size business, because that time it will take to set up that. But compared to this one, if you are choosing that Dockerization, by this single server, we can create thousands of VMs. We can create thousands of VMs within the second. Per second, we can create 2 to 3 VMs like this. This is the, yes, in Dockerization technology, in the containerization technology, we are calling as a container. In the virtualization technology, we are calling as a VM. In the AWS cloud technology, we are calling as an instance. We are calling as an instance. If you are going to traditional technology, we are calling as a physical server. If you go to containerization, they are also required this OS, RAM and processor, networking, everything required. If you go to virtualization technology, yes, these resources are mandatory. If you go to physical servers technology, yes, there also this required. Just imagine it, if you are using one laptop, if you are using that laptop, if you want to use that laptop, yes, that laptop should have that RAM, processor, disk space, networking, display, OS, everything we should have that. Without that we can't run. That's one physical device right now. That one physical device. Of course, some of the guys are using virtualization technology for setting for learning this DevOps environment. Because why you are using this virtualization technology? You can buy a physical servers, physical laptops. You can buy for one master Jenkins master machine, for one slave, one SonarQube, one Nexus. Yes, you can buy Yes, if you have money, you can buy it, no problem. But what is the disadvantage? Maintenance problem. We'll get a lot of issues for maintaining. Can you handle at a time 5 to 10 servers? It's not possible. So that reason, what we are doing that we are buying one high-end laptop. On that laptop, we are going to installing this virtualization technology. On that, we are going to creating these virtual machines. After that, we are going to integrating each and other. That is the one advantage compared to physical. But here also, if you want to create, yes, can you create at least 5 to 10 VMs at a time in your laptop with 4 GB RAM? Can you create 4 VMs at least with 4 GB RAM? If you have that,
No.
If you have that 16 GB, you can create, but maybe you don't have that much of processors. We can't. It's not possible. It is possible. When it's possible, whenever you are going to spending much more money, yes, you will get that physical resources also. But it goes to 1 lakh, 2 lakhs, 3 lakhs, 4 lakhs. Even yes, we are having that 60 core processors also. Already have that 32 GB RAM laptop. In 2016, I think in 2016, I bought that. Still, I have that. But compared to this one, little bit, that is also old. Little bit old. So still I'm facing some problems with the 32 GB RAM also. Lack of processors. Okay, if you are using this virtualization technology, finally we'll get some issues. What is that? These resources issues. That's the problem here. And even if you go to real world, why the industry, why the business people are looking at that cloud side? Why they are moving to cloud? This is the major issue which we are going to discussing. This is the major issue for managing their business. If they want to handle their business in their own data center, they should have at least 2 to 3 data centers geographically in different locations. By one data center, they can't maintain. If the data center will collapse by anyone, human error or any natural error or something, that finally they will lose their data. Forget about the physical devices. Whatever we are having storage, that information inside that devices, yes, we will lose that. For avoiding that loss of data, yes, what we have to do, we need to set up one more data center geographically 200 or 500 kilometers above. After that, we need to integrate these two data centers with one link. Parallelly, we want to store that data. If one data center collapses, yes, we can recover from another one. Imagine it, at a time, the 2 data centers will collapse. What next? Yes, the person should have a third one. Imagine it. If he is maintaining 3 data centers geographically in different places, yes, how much expenditure will come? How much they want to spend? How much they are earning? What is their business turnover? And what about manpower? What about we can't imagine that, no? We can't say that exactly. Yes, every physical server will work perfectly. We can't imagine that, and we can't decide that. We don't know what will happen, when will happen. Which device will corrupt? Maybe yes, processor will corrupt, RAM will corrupt, processor will corrupt, storage will corrupt, motherboard will corrupt, power supply will corrupt. What is that? Network devices will corrupt. We don't know what will happen, when it will happen. For these all problems, yes, the business person is the responsible. He want to spend that money for a recover or to replace the server or for replacing that device. These are the challenges. Already, who are moving to cloud, those people already they saw that with their own data centers. They are not able to managing their data center. So that reason they are looking for cloud environment. They are looking for cloud environment. So that reason, nowadays cloud is an emerging service or emerging tool in the industry. Whatever we have set up or whatever we have created this environment, the same environment we can set up in the cloud also. They are providing those kind of services end to end. They are providing SaaS, they are providing as infrastructure as service, platform as service, software as a service, network as a service. They are providing. But what we should have? We should have money, that's it. For using their resources, we need to buy their resources on rental basis. We need to buy those services instead of using this physical technology. Of course, nowadays, some more new technologies are in the market. Some of the people's coming out from their public cloud who are going to utilizing or who are utilizing that public cloud like that AWS cloud, Azure cloud, Oracle cloud, Google cloud. Some of the people's coming out from that public cloud. Again, they are going to set up in their own data centers with new technologies. OpenStack is a cloud. OpenStack is a cloud, private cloud. We can set up our own cloud environment. Already have worked on that. We can set up our own cloud. If you have 3 physical servers, yes, we can create 200 to 500 VMs. How we are going to creating instances in AWS, like that we can create. If you have 3 physical servers, we can set up that. Nowadays, that's not a big issue for buying 5 servers or 10 servers or 15 servers. Within 2 to 3 crores, yes, we can set up our own data center instead of buying these virtual machines and physical servers. Of course, finally we should have some physical servers. Without physical servers, we can't run. Even AWS also, they are using physical servers. You can Google it. Their data centers you can see in the world. How they are going to managing. They are using that 3-tier, 5-tier, 6-tier technology security they are using for maintaining data centers. Of course. Okay. Here also we are using cloud and we are switching into new technology that's calling as a Dockerization, containerization technology. What are the disadvantages of this virtualization technology and what are the advantages of containerization technology? The problem with virtualization technology, wherever you are using virtualization technology, finally you will reach to end of the point with these physical resources. There is a limit. In this virtualization technology, we are having limit. Limit mean, yes, whatever we saw that processors, 24, that's the limit. Whatever we saw that 80 GB RAM, that is the limit. And what is that? Yes, storage also. And network NIC cards also we are having that 4. Actually, we will get only one NIC card. Only one NIC card. What is that? We are calling that a LAN port. You will get only one port for one laptop. But these business servers are having that 6, 8, 12 high availability. These physical servers are having that high availability. I mean that yes, hard disk, it will come with the 2 RAID levels and 2 SMPS will come and 2 processors will come. Nearly 19 slots are there. 19 slots for RAM slots. Yes, which server I am using, it will support up to 1 TB RAM. I can extend up to 1 TB RAM. Like that. But here also there is one endpoint. There is one endpoint. Finally, we look at resources. Without resource, we can't. But if we go to Dockerization or containerization technology, yes, we can create with this 8 GB RAM, with this 8 GB RAM, yes, you can create 200 or 500 VMs. With this 8 GB RAM, we can create 200 or 300 VMs. Depends on that. If you want to, at least if you want to buy one laptop, yes, it will take 2 to 3 hours from your living location to, for that, what is that, you have to go for shop, no? Yes, you need to go select that, you need to pay that, and you need to collect that. At least it will take 2 to 3 hours. Like that, if you want to set up this physical data center, it will take couple of months to end-to-end setup. See, it's taking 2 to 3 months. Yes, you have decided to set up that your own data center. You got one project or two projects. Yes, you are having your own business also. After 1 year or 2 years, yes, whatever you are having clients, they left from you. Once they left from your business, from your service, yes, your data center is now empty. Now you tell me how you can manage, how you can sell the products. Can you sell the product with the same cost whatever you buy? It's not possible. No one should not buy. Yes, you need to sell for half amount or 30%, 50%, or you need to sell for 20%. You are losing 80% or 50% of money compared to your buying rate. This is the loss of money, no? How you can recover? Imagine it, if you spend that 2 crores or 5 crores of money for 1 year, 2 years, if you are not going to recover that money within 1 year, 2 years, now you tell me, is it a loss of business or profit of business? It's a loss of business. So how you can recover financially? That's the problem. Nowadays, we need not worry about like that kind of business. If you have that at least 5 physical servers, yes, we can set up our own cloud. Yes, we can create 500 to 1000 VMs. Those are calling as instances. Because hardware technology is like that and software technology is also like that. Both are supporting together. Both are working together with a new trend. But we should have that manpower to set up that kind of environment. If you have that perfect manpower, we can set up that. See guys, these are the problems with this virtualization technology. Okay, so I'll start once again. After 2 to 5 classes, we'll come back to this containerization technology, and once again we'll discuss about this virtualization technology after 5 to 6 classes. Because you will learn something, this containerization technology. You will learn something practically. You will get some analyzation practically what you did on the containerization. Already you are having experience working with this virtualization technology. Am I correct? Guys, almost all of you guys are having that experience working with this virtualization technology, VMware or VirtualBox or something. Already you are having experience with this one and you are learning new technology that's calling as a containerization. Once you try to learn that containerization, you will get some idea. Automatically you will analyze yourself only. Then you automatically yourself only will compare with this virtualization and containerization. Which are the heavyweight technology and which are the lightweight technology. Compared to this virtualization technology, Docker is a lightweight containerization technology. Mostly we are using for microservices to run our business applications in the environment. See guys, whenever you want to run one application on physical server, while buying that physical server, we'll plan for a future. Just imagine it, you are having requirement with 16 8 processors with 16 GB RAM. With 16 GB RAM with 8 processors, you can finish your requirement. With the same configuration, you can't buy now physical server. We don't know what will happen in future. Maybe the resources requirement, maybe it will increase. Maybe the 8 processor goes to 16 processors, which we are using present 16 GB, maybe it goes to 32 GB RAM. Maybe our server will go a little bit high because we are processing n number of tasks inside that server. But on today's basis, we can't concentrate. On today's basis, we can't buy that. Maybe we need to spend some more money for future challenges. See, whatever we are planning for future, that's the extra money. That is the extra money. But today only we are spending. But we don't know will we will travel or not with high-end resources. We don't know we will reach or not with high-end resources. But today we are going to investing. Today we are investing. Whatever we are spending extra money, that's a waste of money for today. Like this, whenever you are going to buying that physical servers, you will face like that. But today requirement is different, upcoming requirement is different. For upcoming business also we are spending that money. If you analyze that your business, whatever we are spending that extra money for today's, yes, the complete loss of business, loss of money. But we can't expect that exact results on the future. These are the problems. These are the problems. So that reason, we are using containerization technology. That's a very lightweight technology. That is a platform. That is a platform to simplify our development services, deployments, and the scaling of applications by using containerization. Containerization. It's a lightweight platform from of virtualization. Yes, it allows us to package application running, and we can use that dependencies also, and we are having that consistent environment, and we can ensure that applications runs reliably across different computing environments. Here we are having that. Here we are having with that Dockerization. Yes, we are having that containers, Docker images, Docker engine we are having, Docker files we are having, Docker registry we are having, orchestration we are having, portability and consistency we are having. Of course, you don't know what I am speaking, what I am talking to you. Maybe you don't have that much of idea. Because if you are new to this technology, you can't understand immediately. I'll show that physically. Sorry, I'll show you practically what is that image, what is container, what is registry, what is Docker file. We'll see that. What is Docker engine? We'll see that. Okay. And today's session, just practically, I'm going to introducing that Docker. Practically, I'm going to introducing the Docker. Okay, guys. Yes. If you want to install Docker, we should have one OS. We can install on Windows. We can install on Windows also. But guys, I'm suggesting you should not install on Windows directly. I'm saying that you should not try to install that Docker on Windows machine directly. Once you install that Docker in your Windows machine, automatically this VMware will lock by that Docker. After that, this VMware will not work, because that is also one kind of that virtualization technology. Docker also one kind of virtualization technology. But compared to this one, that is the lightweight, very lightweight. Automatically, this VMware lock by that containerization and operating system. So that reason, don't try to install. You should not install it directly on Windows machine. You can create one VM in the VMware. In the VMware, see guys, now what I'm doing that. Now I'm already have that. Sorry, just I'm going to revision. Yes, just I'm giving that 6 core processors. I'm giving that, and I have that 18 GB RAM, and I'm giving that 16. Okay, for in your case, guys, one processor is enough. One processor is enough, and you can run with 1 GB RAM also. But my suggestion, better to give 2 GB RAM and 2 processors. Whenever you are running this Docker engine or Docker server, you can stop this all. You can stop this all. Okay. Until when you run this Docker, or until when you stop that Docker, better to stop this all servers, remaining VMs. Because whatever we saw that SonarQube configuration, whatever we saw that master slave configuration. So okay, Nexus, everything, this entire environment we can configure on the Docker also. You can see how much it is easy. Okay, 100% you will appreciate about that Docker. 100% you will appreciate to Docker, because that's the one very good tool. So that reason, nowadays in the industry, IT industry, Docker is the emerging tool. It's like a heart in the industry. Who are going to using Kubernetes? Kubernetes is the front end. Yes, back end, the Kubernetes having this container. Without container, there is no Kubernetes. Without container, there is no Kubernetes. Fix it. Before entering into the Kubernetes, we are learning individually about this Docker. Before entering into Kubernetes, we are doing practice on directly Docker. Docker Swarm, Docker Compose, Docker Image, Docker Container, Docker Files. We'll see that. That you believe or not it. Compared to this one, it's very easy to learn also. Very easy to learn. Of course, first 2 days or 3 days, depends on your capture. Depends on your analyzation, depends on your understanding. But I'll try to explain as much as easy. But your side also, maybe you are also a little bit confusion. You can't digest. That is the problem here. Immediately you can't digest that. You should not come into that Docker environment. Already you saw this. Every environment you saw that, and you are having much more working with these tools, this virtualization. So that reason you can't digest immediately. You can't convert into that side. If you want to digest that Dockerization technology, maybe it will take 1 day or 2 days, 3 days time. Until that you will be in confusion. But nothing to worry. Once you learn that Docker, yes, you will decide that compared to these all tools, Docker is the very easiest tool. Very easiest tool. Okay, you will see now. Yes, now let me create one VM. I'm creating one new VM. Yes, already we are having that Docker. See guys, already we are having Docker, but I'm naming that just only Docker. Yes, it will take some time. Just wait until creating that. Okay, guys, I have created. Guys, keep in mind, I'm using on-premises servers. I'm using that whatever you saw that entire this DevOps environment. This is completely on premises. In within few days, within 5 to 10 days, we are switching to or we are moving to cloud side also. Guys, you also be ready with what is that AWS account. You need to configure this entire environment. Whatever we have configured, Sonar queues, Docker, what is that Docker also under what is that Jenkins master slave, Nexus, everything we need to configure on the cloud also. We have to see that one also. Yes, take the IP. Yes, 132. Guys, here also one thing problem, because we will get tabs. We will get tabs. If you want to understand easily, we should have in single tab, single line. So that reason I'm not going to increasing much more size. You need to adjust. First of all, let me show you that. Okay, I'm going with a regular size. Okay, yes, now I'm going to naming that. Yes, host name ctl set hyphen host name Docker. Okay, exec bash. See guys, rpm space hyphen qi Docker hyphen ce. Here we don't have that Docker. Now we need to install that Docker. Docker is the command. Docker is the here parent command. Like that, how we executed a git command. While executing git commands, always what is the first command or parent command? Git is the parent command. Always we should apply the first command git. After that, we need to apply options. Here also, there is a parent command. Docker is the parent command. If you want to say something to Docker, or else if the Docker want to listen you, you should apply the first command Docker. Then only it will accept your conditions, your commands. Otherwise, command not found. Command not found. Okay, guys. Let me show you that how to install Docker. Yes, guys. Here we are having on our site cloud-devops.in. Here I have that Docker. Sorry, not a Docker. Git and some Linux commands and all. Still, it's under development. Okay. Now you can click on that Docker. Click on the Docker. Now you can find that Docker installation, and you can see that, guys. What is the need for containerization? What is the difference between VM versus container? Why Docker? Okay, introduction to Docker. You can see that. Okay, or not having complete documentation. Okay. Now, guys, you should not install this one. Keep in mind, you should not install this one. If you install this one, we will get very old version. Very old version. Okay, but you need to start from here. This is a little bit old document, but yes, you can use, you can in the CentOS also. In the place, you can use CentOS 8. In the place, yes, you can use a Red Hat. Yes, in the, what is that? IAM, Amazon Mission Image also you can use. Under Rocky Linux also you can. And OEL, Oracle Enterprise Linux also you can use these commands. Okay, see guys, now we are going to installing some prerequisites. Install, mutils, device mapper persistent data, and LVM2. we are going to installing these three packages. We are going to installing mutils, device mapper persistent data, and LVM2 we are going to installing. Yes.
Uh, Meanwhile, I have one doubt. In Git, there is an option like Git download. There we can go to the new version, which version we want to download. We went there. No. Similar way, is there is any a Docker download? Is there is any link like that?
No, they are providing that this is the latest version we will get. Directly, we will get that latest version.
Okay.
Okay. So now at present we don't have that repo, Docker repo, Docker CE community enterprise. Docker community, we are having that enterprise edition and community enterprise. So community enterprise is the pre-version that we will get the latest version. Now we are going to creating that repo for installing Docker. Yes. Now you can install install Docker CE-Y. Very simple. Just with the 3 steps only we can. Okay, guys. Yes, successfully we have installed. Now you can ask that one more again. RPM space -Q only Q Docker -C. See, guys, we have installed. This is the latest version to 24.0.7-1. And if you want to get some more information, clear information from the Docker, just apply that -I. See, guys. Okay, this is the complete information. Next, coming to Docker official message from the Docker developers. If you ask the question, if you ask to Docker developers, what is Docker? They are saying, they are giving this description about Docker. See, guys, Docker containers are both hardware agnostic and platform agnostic. This means they can run anywhere from your laptop or to the largest cloud compute instance and everything in between. And they don't require you to use a particular language or framework or packaging system. See, guys, that makes them great building blocks for deploying and scaling web applications, databases, and backend services without depending on a particular stack or provider. No need. No need. Okay, we'll see that. We'll see that. Okay. Now successfully we have installed. After that, keep in mind, in this DevOps environment, I think already I have explained you, but once again I'm reminding you. Once you install the application or software, that can't run immediately. that can't run itself. As a software engineer or package manager, you need to start the service. Now you can ask the mission system CTL status Docker, only status Docker. Don't apply that to CE. Up to install and checking software installed or not, only CE. But if you want to work with Docker, just apply that only Docker. Now we are coming into Docker service. Now we are coming with Docker service. We are trying to work with Docker. If you want to work with Docker, that Docker service should be in the running state. Now you can see that active state is inactive dead. Now what you have to do? We need to start that system CTL start Docker. Now you can ask again status. See guys, it's running. If you don't want to start on every restart or reboot or starting time, just apply that system CTL enable Docker. From next time, system only it will take care of running the Docker service. You need not to start manually. Okay, fine guys. Now Docker service is running. Now guys, see here, keep in mind, this is the important thing here. Whenever you are seeing that, just I'm naming that host, guys. I'm naming that host name CTL host name Docker dhost, guys.
Spelling error. Host name CTL.
Okay, thank you. Just I'm naming that dhost. Dhost means Docker host mission. Wherever we are going to installing, on which mission, either physical or virtual, either on premises or on cloud. Wherever we are going to installing that Docker software, after installing Docker software and on one OS or one mission, from the time that mission calling as a Docker host mission, that OS or that mission hosting this Docker software. From the time, that is the responsibility to run or to work with this Docker. For managing Docker services, for running that Docker services, that mission is the responsible on these Docker services. From that time, it's calling as a okay. From that time, it's calling as a host mission. Just I'm naming that instead of Docker. Just imagine it. From this time, it's calling as a dhost. Dhost means Docker host. Why I'm going to this much simplifying? Because we will get a number of tabs. Sometimes we will get a lengthy command. It goes to second line. For avoiding that confusion, just I'm naming that simple name Docker host. Next, you can apply that exec bash. See guys, keep in mind, this is the important. See, same place, same like in the Docker container also. Keep in mind, Docker container also one VM. That is also one server. But in the virtualization technology, we are calling as a VM. In the cloud technology, in the AWS cloud technology, we are calling as instance. In this Docker, in the Docker environment, we are calling as a container. Keep in mind, whenever you are going to executing or whenever you are working with containers, you need to feel that is also one VM, that is also one instance, that is also one server, but it's calling as a container in this Docker terminology. In the Docker terminology, we are calling as a container. That's nothing but a VM. VM nothing but a server. It is also having its own properties. It can act as a bare metal OS. If you have that hardware knowledge, hardware and software integration knowledge, this container also can act as a bare metal. Okay. Now we are starting with Docker. The first command, Docker info, Docker information. See guys, how many CPUs we have given? 6 CPUs. Virtual CPUs we have given that. And OS architecture 64-bit, OS type Linux, operating system Rocky Linux, kernel version. You can see that. Okay. And coming to Docker root, where we have installed, yes, this is the Docker root path. Next, coming to Docker server. In the server, number of containers are running. Total number of containers 0. Total number of containers 0. Running containers 0. This is the first count. Out of this total containers, maybe running containers are inside these total containers, paused containers also inside these total containers, and stopped containers also inside these total containers. And here overall 0. Overall 0. Next, coming to images. Total images are 0. Total images are 0. We need to be discussed about these two. These are the main, and these are the playing main key role in the Docker environment. Okay. Next, the Docker server version and the storage drive overlay, storage driver. Okay, we'll discuss what is driver. Okay, next, backing file system XFS, support data type true, using meta copy. We didn't configure that. We'll see that. Native overlay difference true. See guys, this is the information about, little bit first information about Docker. Next, okay, Docker version. See guys, here we are having, keep in mind, here we are having two parts. One is the Docker engine. One is the Docker engine and one is the Docker server. One is the Docker server and one is the Docker engine. And we are having both here, client and server. The server side Docker engine is there, and the client side also Docker engine is there. You can see here. For both client and server, we are having same version, single software. See, client Docker engine. We'll discuss that. Interview question: what is Docker engine? What is Docker engine? We'll discuss later on that. Okay, this is the Docker information. Yes, a Docker hyphen version. Sorry. Docker hyphen version. Only single line. Only single line. If you remove these hyphens, you will get much more information about this Docker. Only Docker information. It's a service information. If you go to Docker info command, that command, it gives you much more information about images, about containers, about what is that networking, and about architecture, OS architecture, and number of processors. Okay, yes, everything information we will get. Now guys, now we are starting with the Docker commands. Yes. Okay. Okay. Guys, are you ready for next 15 to 20 minutes? Okay, guys. Yes, so commands. First command, systemctl status docker. Systemctl status docker, is the service running or not? This is very important. Next, if it is not running, systemctl start docker. If you don't want to run every time and every reboot time, yes, you can apply that systemctl enable docker. That's enough. Okay. Sorry. Next docker version hyphen version. Next docker version. Next
So, Docker info.
docker info. You saw that. Okay. So we'll write that narration also from next class. So now, guys, now we are checking that Docker images. We'll discuss in tomorrow's session. It's very, very important. Okay, within you can't understand within 1 or 2 minutes or 5 minutes. Okay, so that reason we'll discuss much more about this image about these images in next class. Okay, next Docker PS. Docker PS hyphen A. Docker PS hyphen A. Now Docker pull hello hyphen world. Next Docker PS hyphen A. Next again Docker images. We'll remove that repeated commands. We'll remove the repeated commands after understanding about concept. Now guys, so what it will do now? Yes. Okay. To see the, if we want to see the images, if we want to see the Docker images in, don't ask me what is image in today's class. Of course, you are having right to ask on that. Okay. But let me explain before your question. But already I told that no, in today's session it's not possible. Yes, to see the images in a local server or local registry. Next, see, okay, this command used for to see the only running containers. Next, this command used for to see the all types of containers. All types of containers. What are the all types? How many types? We'll see that in next class. Yes, this command are here. We are pulling our Okay, that's the default word. That's the terminology word. We are pulling the Docker hello world image. Here, hello world is the image. Hello world is the image. So why we want to pull that? We have configured a Docker. We have installed a Docker. Is that Docker is okay or not? Is that Docker working or not? We are testing. We are testing by this image. By executing this hello world image, we will get information from that image. That image gives us information about our Docker system. Is that Docker working or not? Okay. Next, after pulling that, if we want to see the images, same one. Where is this? Yes, same answer. And again, this is also same. This is also same. Because first of all, we are seeing that. First of all, we are seeing. This is also we are seeing. This is also we are seeing for our understanding purpose. After that, what we are doing that? We are pulling that. Here is the 0 images. If you apply right now, if you apply that command immediately, yes, Docker will pass or Docker gives you message 0, 0 images. Okay, and if you apply this command immediately, you will get yes 0 containers. And if you apply this command, you will get 0 containers. Now what we are doing that we are pulling one image. Now we are pulling that one image from the Docker hub, from the hello world image. What is this? We are pulling the Docker hello world image from Docker hub. What is hub? We will discuss in next class. Okay. Next, after pulling that, we are seeing that before pulling this, yes, there was 0 images, 0 containers. Okay. Now let me show you that. Yes, Docker images. See, 0 here. Repository nothing but image ID, image name, tag, image ID created when it was created and its size. Next, coming to containers, Docker PS. This command used for to see the only running containers. Which containers are in active state, in running state, or in up state. Those containers only we can see. Okay. Next, here we don't have any kind of container. Next, Docker PS-A. Here we are having 3 types of containers. One is the running container, paused container, and stopped container. Stopped container is calling as a exited container. Keep in mind, exited. Guys, keep in mind, exited. Whenever we are applying that Docker PS command, that time you need to understand exited command. Exited means which containers are in running or paused state. Which containers are not in running and paused. That container will be in exited state. It means stopped state. At present, we don't have commands. Containers. Now what we are doing that? Now we are pulling that Docker pull hello world. See, successfully we pull. Now you can see that Docker images. We got one image, but before that, see, here 0. Now we are having one image. Repository nothing but it, image name and latest image ID 8 months ago, and the total size is 13 KB. Next, Docker. Now we are running that image. Docker images. Docker run -it or -it space, what is that? Hello world. See guys, this is the message from the Docker. Hello from Docker. This message shows that your installation appears to be working correctly. See, to generate this message, Docker took the following steps. See guys, it's the message. Finally, we got that success from the Docker. Successfully we have installed Docker, and we tested that. But these Docker developers are recommending Ubuntu OS. No problem. We can work with Rocket Linux, and we are working with CentOS. We are having different operating systems here also. We'll see that. Okay. Thank you guys. Okay, that's all in today's class. We'll meet in tomorrow's session. And please let me know if you have any doubt your end.